Good afternoon. We are going to be looking at the questions on exam 3 that was missed by more than 80% of the overall students. Okay? And so we're going to begin with question number 4, which requires a little bit of vocabulary knowledge to be able to answer. So it says, name a pair of complementary angles in the picture. So, of course, the first thing you need to remember is, what does complementary mean? And if you will remember, we talked about this, way that you can make complementary 90 degrees to sort of help you remember that complementary is 90 degrees. So you know you're looking for a pair of angles in this list that when you add them together, they are 90. So QRV is 90 all by itself. So it's out. VRW is 60. SRW is 30, which when we add gets us 90. QRW is more than 90, so it's off right off the bat. And then QRV and VRW. Well, QRV all by itself is 90, so it's out. So it looks like this is indeed the pair of complementary angles, VRW and SRW. Okay, moving on. Let's look at question number 8. So we talked about this. We didn't really work a lot of problems with it, but we did talk about when we're looking at a dilation that everything has to change in proportion with one side. So if I double or half a side, then all sides have to be changed in that same way. So if you remember, this is where I said if we were going to enlarge this on like Word, you'd have to grab the corner so everything moved in scale. Okay? So it says which one of these could not be an enlargement or a reduction, which we call a dilation. So we're kind of looking at what is the factor that takes us, or scale factor that takes us from image to image, right? So 8 divided by 2 is what gives us 4. So we check to make sure that 12 divided by 2 is 6, and the same operation happens, right? And then we think, okay, what would take us from 8 to 9? What would take us from 8 to 9? And so we would actually need to calculate 9 divided by 8 in order to figure out. Okay, so it looks like 8 times 1.125 is 9. So we want to just make sure that 12 times 1.125 is 13. So I'm just going to multiply that, and I get 13.5. So it looks kind of like it's probably going to be this one, but I can actually check the other ones. So to go from 8 to 10, I would do 10 divided by 8 to see what it was multiplied by. So 8 times 1.25 is going to give me 10. So then I just want to make sure that 12 times 1.25 is actually 15. So 12 times 1.25 is indeed 15. So this one checks. And then what would take me from 8 to 12? Again, I do 12 divided by 8, and I get 1.5. So I know that 8 times 1.5 is going to give me 12. So I'm just checking 12 times 1.5 to make sure it's 18. So let's see. Let me try that again. 12 times 1.5 is, yes, 18. Right, so that checks. So this is the only one that does not indeed does not indeed check because we end up with 13.5 instead of 13. Okay? All right, moving on. Question 11 says which equation represents the circle. So remember, it's going to be the opposite sign, guys. So the first thing I want to do is, first of all, what is the equation of a circle? Okay, well, it's x minus h squared plus y minus k squared equals radius squared. Then I need to figure out what does hk equal. So what's the center? The center is negative 5, 1. And what's the radius? The radius is 1, 2, 3. And then I just need to plug in, right? So h is going to be negative 5, k is going to be 1, r is going to be 3. So it's going to look like x minus negative 5 squared plus y minus 1 squared is equal to 3 squared. This right here becomes x plus 5 squared. This right here stays y minus 1 squared. And then 3 squared is, of course, 9. And that looks like, let's see, we can get rid of these guys. And so we're looking at this guy right here. Okay. Moving on to question number 13. It says, in the diagram below, a parallelogram of rock, ROCK, let me try that again. In the diagram below of parallelogram rock, ROCK, the measure of angle C is 70 degrees and ROS is 65 degrees. Okay? So those are the two pieces of information that we need to be able to answer this question. So kind of thinking about what it means to be a parallelogram, you know, in a parallelogram all opposite sides are parallel to each other. Well, that means we have a transversal cutting through two parallel lines. So I actually, if I think about these parallel lines, I actually have alternate interior angles, and kind of think about it like if I can make a Z, then I know those angles are going to be equal to each other. So I'm just talking about, looking at this picture, kind of what do you know is true, right? So then we want to think about, you know, totally separate. If I totally separated these questions, you know, just the parallelogram all by itself, right? If I think about them as intersecting parallel lines like this, okay, then here is parallel lines cut by transversals that are parallel lines. So if I turn it, then this angle and this angle, right, are actually same side interior, which are supplementary. Same with these guys, right? This one is going to equal this one because they're same side interior. And so, not equal, but add to be 180 and add to be 180. Okay? So, I know that this whole angle plus this angle is 70 degrees. Is 180. Let me say it again. I'm twisting my words here. This whole angle and this angle is 180 degrees. So if I take 180 and subtract 70, I'm going to get 110 degrees. So this big angle, this one, is 110 degrees. All right, this one was 70. So this split, this 65 in something is going to give me 110. Right? So if I wanted to know this angle, I could take that 110 degrees that I found, subtract the 65 degrees that I'm given, and I will end up with 45 degrees right here. Now remember, we just talked about this is alternate interior with this, which is all well and good. The problem is This question actually asks for KSO. So KSO is this angle right here. But that's okay, because we have a linear pair here. So I can just take 180 and subtract it with 45. And that's going to give me 135. A little confusing. But remember, in a parallelogram, in any parallelogram, these two are supplementary, these two are supplementary, these two are supplementary, and these two are supplementary. Because no matter how I turn this, they're same side interior. All right. For the 400th time, line L passes through the points -15, 4, and 5, -6. Which of the following lines would be parallel to L? I should see this word and immediately think same slope, right? So what I'm looking for is, what's the slope from these 2 points? So I can find the slope by looking at change in y over change in x, which you learned last year, formula for that, y2 minus y1 over x2 minus x1. So if I go to my points and I think about this as x1, y1, I think about this as x2, y2, then we have -6 minus 4 over 5 minus -15, minus a negative becomes plus. That's going to give us -10 in the numerator, 20 in the denominator, which is -1/2. Parallel, same slope. Slope is -1/2. I come over here. Slope is -1/2. Okay. Moving on. Looking at question 17. Question 17 says the circle in the standard XY coordinate plane below has center -8.5, 7.5, and has a radius of 5 coordinate units. Okay. So it says the circle is reflected on the y-axis, and I've labeled the axes for you. So that means it's going to be the same distance, just on the other side. Okay? So if I were to reflect this over the y-axis, it's now over here. So the y stays the same. The x, though, is reflected to the positive side. So the center of the circle will be now +8.5, +7.5, because it's been moved into quadrant 1. So they both have to be positive now. If I take that original circle and I reflect it over the x-axis, right? So now I'm going down over the x-axis. So it's down here. I'm now in quadrant 4, where both of the x and y coordinates are negative. So now my answer is -8.5, -7.5. Right? So I reflected over the x-axis, the y changed signs. I reflected over the y-axis, the x changed signs. Kind of a strange thing. Then it says the original circle will be translated 8.5 units to the right and 5 units down. So this is that translation concept that we've been talking about all week of, we can move stuff. We can just translate it. So if it's at -8.5 and I go right 8.5, then it's now at 0. And if I have gone up 7.5 and I go back down 5 units, then I'm now at 2.5. Right? And we didn't, talk about it this way, but one thing that might help you is think about the coordinates of that center, negative 8.5, comma 7.5. And if I'm going to go to the right, that means my numbers are getting bigger. And this would be x-axis, because the x-axis is the one that goes right and left. 8.5 to the right. So I'm going to add 8.5 because I'm going right. But then I'm going to go 5 units down, and that would be on the y-axis, and I would be decreasing. So I'd actually subtract 5 from this one. And if I just apply that, this becomes 0, and this becomes 2.5. So I could think about it that way. It's a little less intuitive and a little more just, number sense kind of thing. But just be literal when you're moving stuff around. So don't overthink it. Okay, question 19 says, determine which of the following represents the length of the diameter. So you've got some options here. You can do distance formula, which I think is the intent of the question, right? So if I do distance formula, that's the square root of x minus x squared plus y minus y squared, which is going to be 4 squared, or negative 4 squared, which is 16. And this is going to be 4 squared, which is 16. So this is going to be the square root of 32, which is 5.657 here. Now, if you had forgotten the distance formula, what you could have done was created a right triangle where your hypotenuse is the distance you're looking for. Okay? So if that's the case, then to go from 2, so think about the x-axis, to go from 2 to 6 is 4 units. And to go from negative 1 to negative 5 is 4 units, right? So that's your change in y and your change in x. Or your distance in your y's and your distance in your x's. Same thing, different verbs. Which is 4 squared plus 4 squared equals c squared, which is this. Because really what happens is you're going to say, okay, 4 squared plus 4 squared equals c squared. 16 plus 16 is c squared. 32 is c squared. Take the square root. We don't need plus or minus because it's the side of a triangle. And we get 5.657 that way. So exact same problem, 2 different ways. Okay. Moving on to question 20. Question 20 says, points 2, 5, and 8, 11 lie in the standard coordinate plane. What is the midpoint? And I almost had a heart attack when so many people missed this question. Guys, the midpoint is the average of the x's and the average of the y's. Okay? I know I didn't talk a ton about midpoint, but it's definitely something you need to know. So I can average the x's, and then I can average the y's. So this is 10 divided by 2, which is 5, which kills these. And then 16 divided by 2, which is 8. And then the other midpoint question, but this one was the harder one. But we worked one exactly like this. In the standard xy coordinate plane, the point 2, negative 4 is the midpoint of the line segment. The endpoints of the line segment are 8, negative 8, and something, right? So think about the midpoint formula. Here's x1 plus x2 divided by 2, y1 plus y2 divided by 2, right? And we know one of the x's and one of the y's, and we know what it should equal, right? So we know that 8 plus x2 divided by 2 has to be 2. And we know that negative 8 plus y2 divided by 2 has to be negative 4. So multiply by 2 and you get 4. Subtract 8, and you get -4. Multiply by 2 on the second one, and you get -8. Add 8, and you get 0. All right, study up. Some of you are going to want to replace this test score with whatever you make on the final exam. So make sure you are ready to go.